All right, so we are live. So does anyone want to say the opening prayer?
I'll say.
Okay, cool. Thanks.
Dear Heavenly Father, we're so thankful for all of our blessings. We're so thankful for all that was done for us and for this great day that we had so far. We're thankful for this chance we have to meet together as a group for our statistics class, and we ask you please be with us. Help us be able to understand and learn from each other, and we love you so much and ask this in the name of Jesus Christ. Amen.
Amen.
Yeah.
Thanks. All right. I guess the first thing is how'd everyone do on the individual assignment?
Good. I did okay.
Yeah, it went pretty good. I struggled a little bit on some of the questions, just trying to figure out how it makes sense, but we'll get to that.
Did we want to discuss any of it? Did we have any questions we want to discuss with each other? Or?
I'm good.
Are we going to go over part 2 in this homework assignment?
Yeah,
we can.
Yeah, I think we're supposed to, so we might as well.
Okay, let me pull that up really quick.
The only problems I had were on 14 and 15, and then I realized I was using the wrong numbers.
Oh.
Let me get mine ready.
Other than that, I was fine.
Sorry. Pulled up, but I had up the chapter instead of the individual assignment, so sorry.
Okay.
That's lesson 7.
Quick question, was lesson 4 group collaboration the one that we did the last time that we met? When we had all the problems?
Was that lesson? I think that was. Okay, what about it?
Was that lesson
6?
Was that lesson 4?
Well, we're on 7 now, aren't we?
Yeah.
Oh shoot. Okay. All right. Okay, I just got my lessons a little mixed up, like which number is which.
Okay.
All right, I'm good though.
All right.
Anyways.
So the preparation assignment for lesson 7.
Yeah, are we supposed to go over that?
Yeah, go over at least part 2 of it.
Okay.
Which is a lot.
Yeah. There's quite a bit on it this time.
Yeah.
All right.
You guys there?
Yep.
Yep.
So we can start with number 4, I guess. Is that how we're going through just each one?
Yeah. So I'll go ahead and read the top part where it says suppose paired computing sold an average of 45 P phones per minute in 2011. Yes, that means that many phones in 2011 with a standard deviation of 10, and they looked at their phones sales data or samples of size 4 are taken from a normally distributed 2011 sales data. What is the shape of the distribution of X? Let's say that it's normal.
Mm-hmm. Okay.
How do you get to that reading again? I'm only seeing like YouTube videos for the lesson 7 part 2.
Go to preparation assignment on the top of that.
Yeah.
It'll come up with a Word
then-
document.
Okay. I found it again. Okay, so we're on 5 now?
Yeah.
Okay, I'll read it.
Okay.
It says samples of size are taken from the normally distributed 2011 sales data. What is the shape distribution of? Is that right?
Yeah.
Hmm. I'm not sure. I might need some help on this one.
I think it's going to be a normal distribution on that one, I think,
Mm-hmm.
because it's over 40.
And it's taken from a normal distribution.
Yeah.
And so it's going to be normal pretty much either way. That's why number 4 was normal as well.
Yeah, there are 2 rules for a normal distribution of samples, and that's if the sample population was normally distributed, or if you have a sufficiently large sample, and that only means over 30 samples, and that's the central limit theorem.
Mm-hmm. So that one's normal.
Yeah.
Okay.
All right, I'll do number 6. A sample size of 4 is taken from a normally distributed 2011 sales data. What is the probability that observed that X is less than 40? And I got 0.1587. And I did that using the z-score, which was 40. Z-score was -1. And I use a normal probability applet.
So how did you get the -1?
Hang on. This thing is not working for me. It's not working. There we go. I got the -1 using the formula for the z-score for the standard distribution of sample means. The score of 40 minus mean, which is 45.
Mm-hmm.
That total divided by the standard deviation divided by the square root of n. So basically it was 40 minus n divided by the quantity of 10 divided by 2. And that gave me a z-score of -4. And I've got the formula plugged into an Excel sheet. To get the z-score of the normal samples, the formula was the score minus the mean divided by the standard deviation, right?
Mhm.
You guys remember that one?
Yeah.
Okay. So when we're talking about a sample of means, you take the standard deviation divided by the square root of our sample size, and that's what we divide by instead of just a standard deviation.
Okay.
Okay.
That makes sense.
Mm-hmm. I think so. I'll know if I get the next one right.
All right.
Wait.
So a sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X bar is greater than 35 and less than 55? This one I wasn't quite sure, so if someone knows how to explain it, that'd be awesome.
Yeah, if you take a look at this one, you really didn't have to do any calculations, but you could. Take a look at 35 and 55. They're both one standard deviation away from the mean of 45.
Okay.
So 95% of your data there.
So it's just in that 68, 95, 99%
And
thing.
yeah, but that's of the regular one. So it's actually, because this is sample data and we're dividing, it's actually 2 standard deviations away. You're basically dividing the standard deviation by 2 because your sample size is 4 and the square root of that.
Okay.
So if you did your 35 minus 45, you get 10. And you're going to divide that by the quantity of 10 divided by 2 or 5. You're going to get 2 or -2 for either 35 or 55. The normal probability outlet. Just type in -2 and highlight just a central area. Come up with 0.9545.
Okay. Okay.
That makes sense.
Yeah. Thanks, Pete.
Sure.
So number 8, a sample size 25 is greater. It is taken from the normally distributed 2011 sales. What is the probability that the X is greater than 41 and less than 49? So that will take So if I did it right on the on my Excel sheet, the z-score would be negative 2.5, and then that gives me an area of 0.0062.
I got -2.
But I think I might be wrong. Oh no, I was right. We're good.
I got -2 on that one.
-2.
Yeah.
Let me see.
For a z-score.
Oh, and from your Excel?
Yeah.
So the mean is 45, the standard deviation is 10, the sample size is 25, and X is 4. Oh wait, X isn't 40 anymore, huh?
X bar is 50, or X bar is greater than.
Oh, shoot. Oh. Okay. You're right. So that would be 2. Let me go to the probability applet. Just put in 2. Okay. So it'd be about 95.
Yep.
Yeah.
Because it's in between those two. And I guess that's still in that same. I guess that was the same as the other one where I could have just done the rule of 68, 95, and 97.
Yep.
But yeah, it's about 95%.
Okay.
Okay.
All right. So number 9 then.
Probability app on the applet it's 90.9545, but same.
Okay.
Okay. Okay. So Mitch, you have 10?
All right. I got 10. So samples of size X are taken from the right skewed 2010 phone sales data. What is the shape of the distribution of X? This one I kind of had a hard time on too. I couldn't really figure out. I don't know. Was anyone else able to figure it out?
Yeah, it's going to be right skewed.
So since it's taking the information from a right skewed data, it's still going to be right skewed because the sample size is so small.
Mm-hmm.
Okay. But if it's bigger, is it not?
Yeah.
Okay. Would it be left skewed if it was like a bigger
No,
sample?
it will be normal. So like number 11 is going to be a normal because it's a larger number, a larger
Okay.
sample size. So it's going to be a number 11. The answer is normal.
Okay.
because it fits into that theorem, the central limit theorem.
Mhm.
And so it follows one of the rules of it being the larger sample size.
Laura, you just answered question 11 and 12.
Oh,
Awesome.
Right.
Well, we could probably just jump to 13 then.
All right, I'll take 13. And did we go over 9?
yeah, Sean did number 9.
I think I did 8.
Did you? I thought you did number 9. Sorry.
That's okay.
That's I'll do 13. We'll come back to 9. Sample size of 4 is taken from the right skew 2010 phone sales data. Probability that the observed sample mean is 35. Can you compute this probability using a normal probability applet with the information you have? No. Why is that applet is only for a normal distribution? It won't give us an answer for right skewed.
Okay. Yep.
Sounds good.
You guys froze on me for a second, but I agree.
Okay.
Okay.
All right.
Is it my turn?
Yeah.
Okay, number 14. A sample of size n equals 36 is taken from the right skewed 2010 phone sales data. What is the probability that the observation x is greater than 36.5? Huh. This is where I kind of got stuck too. I'm not positive how these ones work because it's right skewed. I can't use the probability applet.
Yes, you can.
Because
I can.
it will be a central, because it will be a normal, because you're over the.
Oh, because I'm over. Okay, you're right. Okay. So the mean average is 40. The standard deviation 12. X is so for the z-score, I got negative 1.75.
Yep.
For the applet.
What was the z-score? 1.75?
Negative 1.75.
Okay.
So the question is if it's going to be
What's the probability?
greater than 36.5. So we'll highlight all the right ones. We got about 95.99.
Yep. That's what I got.
Yep. Or 0.9599.
All right. So am I on number 15?
Yeah.
All right. The sample size is taken from the right skewed 2010 phone sales data. What is the probability that the observed is between 37.5 and 42.5? I wasn't really sure about this one either. Would it be somewhere between like the answer to 14 and 100%.
Not quite.
Well, how do you answer that one?
Z-score. The Z-score for 37.5 is going to be negative 1.25. Or 42.5 is 1.25. So you can use either one of those in your normal probability applet. So I just go to the right one, type in 1.25. And I just highlight the area in between the two Z-scores. And that gives you your answer and your area up top, because your area and your probability are the same thing.
Okay.
Do you know what the probability applet is, Mitchell?
Not, I mean, a little bit. I've been kind of struggling with this chapter. It's gotten really hard for me, but not really.
I'm going to send you the link, and you can pull it.
Okay.
I just put the link on the chat on our group thing here.
Some thanks.
Yeah, that one.
Yeah,
Cool.
I'll save this on my computer here. Oh wait, yeah, I know what this is. Yeah, I guess I just forgot what comes up, like what comes up when you click on it. But yeah, I've used this before.
I just leave it bookmarked.
Yeah, I'm gonna just go ahead and bookmark it. Alright. So, are we on the quiz now?
Yeah, what was the area for that one?
It's 0.7887.
0.7887. Okay, I was just checking to make sure I got it,
Okay,
what you guys got on that.
perfect.
Okay, all right. Okay, so now let me pull up my quiz here. Let's see here. Okay.
Alright. I don't want to rush anybody, but I actually gotta go at 9 here. I think it's 10 o'clock there.
Mm-hmm.
So, I mean, I guess we get done what we get done, but I don't know if we don't get it done, I may not be able to finish it with you guys. I just gotta go at 10.
Okay.
Okay.
Right.
Let's get as much as we can done.
So 1 and 2 are easy.
Yeah.
Computer's going.
Always get those ones right.
Okay.
All right.
All right. So
probably question 3.
Okay.
Using the normal probability applet, find the combined area under the standard normal curve to the right of E equals 1.358. And to the left of negative 1.358. So we would highlight the areas on the outside. Am I reading that right?
Mm-hmm.
Okay, so I have 0.1745, which should be rounded to 0.175.
Yep. That's what I got.
Sorry guys, my computer's going slow, so I'm still trying to open up the quiz.
Oh, okay.
I'm just gonna open it up on my phone. There it is.
Did it open, Sean?
Not yet. I'm just opening it up on my phone to do it that way instead. I think it'll be a little faster. It's
Okay.
weird. I think it's just iLearn is freaking out on me rather than my computer because I can hear you guys, see you guys. Okay, now I'm there.
Okay.
So you said what was the answer for 3?
Number 3, 0.175.
What was 3?
0.175.
0.17. Okay. Cool. I can go on to the next one if you want. Which of the following will have a smaller standard deviation? Population. Distribution of an individual observation, the distribution of a sample means. This cannot be determined from the information. 9. Distribution of an individual. I honestly have no idea.
I wasn't sure. I was thinking Pete, which one were you thinking? Because I wasn't sure if we can determine it from the information given, but
I think it's the distribution of the sample means.
is it the sample mean?
I think so.
Okay, I was kind of jumping between that one and cannot be determined, so we go with the sample mean.
Sounds good to me. So, question 5. It says, which of the following results implies that the spread in X decreases as the sample size increases? Would that be the central limit theorem?
Mm-hmm.
No.
Nope. I was totally wrong.
Okay, wrong.
The central limit theorem applies to the shape
Oh,
of large numbers, applies to the spread.
okay.
Okay.
Good thing we have you, Pete.
Yeah.
I was confused on that during homework 6. I wanted to ask that question and I got it wrong because I had said the opposite. So I remember that.
Okay. I would have got that
Okay.
one wrong because I went with central limit theorem. I was like, yeah, that's it. Okay,
Sounds right.
Guys, so which one is it?
it's the law of large numbers.
Okay. I figured. All right.
Okay, so I'll do number 6. So the scores of the quantitative portion of the GRE are approximately normally distributed with mean. The mean is 150.8 and the standard deviation is 8.8. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? So I could be totally wrong, but I got 1.045.
What's Pete say?
I got 1.045 or so, yeah.
So I got it right?
I think so. 1.045.
Yeah. Okay.
Sorry.
My turn?
Yep.
Okay, what is the probability of a randomly selected score above 160 on the quantitative portion of GRE? So, let's see, what was this? 1.045. I got 0.148.
Did you say 0.148?
Yes. Is that what you got?
Okay, that's what I got too.
Okay.
Sorry, what was I kind of lost you guys for a second. What was question 6?
Number 6 is 1.045.
And question 7 is 0.148.
Uh-huh.
Okay. So number 8, a random sample of 5 students was selected to take the GRE. Their scores are those. What is the Z-score corresponding to the sample mean of these students' scores? Round your answer to, okay. So the sample mean. So I need to get the mean of these. 0, 1, 5, 1, 6, 3, 1, 9, 1, 3. It's 160. Hmm. So if I'm doing this right, I'm not sure, but I just got the mean of all those and the standard deviation of all those. And then I need to get the z-score. So the mean is 160.
Mhm.
The standard deviation is 10.05. And there's 5 students.
I need the standard deviation of that.
Oh, I don't. What's the z-score corresponding sample means? I thought you needed the standard deviation to calculate the z-score.
You do, but the standard deviation is
8.8.
8.8. And your sample size, n equals 5.
Oh, I didn't know we had all that. Okay. So the mean is 150.8. Okay.
That's how I figured it out.
The sample size was 5.
Mm-hmm.
Did you get negative 16.568?
For the z-score?
Yeah.
No. I got 2.338.
That's what I got.
Are you
So you
using the formula?
Yeah, you use that formula. So you go 160 minus 150.8 and then divided by 8.8. That's divided by the square root of 5.
Oh.
Hey, sorry to interrupt you guys, but I actually gotta get ready to start heading out.
Okay.
Do what?
Yeah, I gotta start getting ready to head out. So maybe if you guys could you send me a link to this video chat?
Yeah,
So I can watch the rest of it.
sure thing.
All right.
Okay. See you,
Okay.
Mitch.
Thank you.
All right. Bye.
All right. We'll see ya.
All right, have a good one, Mitch.
I missed you guys again and blocked out. Do you have to leave, Mitchell? Oh, he's gone now? Okay.
Yeah, Mitch left.
Okay. So the 150.8 minus 160.
You go 160 minus the 150 point,
Oh, right. Minus 1. That's what I have in my Excel.
and then you go.
You got 2.338.
Yeah, that's the z-score
That's the
is.
z-score.
Mhm.
And then the question What is these scores corresponding to? Oh, so that should be answers to 8, right?
Yeah.
2.338.
Uh-huh. Do you understand how we got that?
Yeah, yeah. For some reason, I was thinking that I didn't have the information up at the top of all these to go
Oh,
off
okay.
of, and so I was just getting the mean of these 5 numbers and the z-score of those. Yeah, that didn't make any
Okay.
sense. So now I got you.
All right. Just making sure you understood how we got that.
Yeah, we're good.
All right. So my turn
Yeah.
or yours?
Is it mine? I go.
Sure.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So I hope I did this right. I don't know. The probability stuff I kind of messed up, but I got 0.0097.
That's what I got.
Okay.
So with that, you
I put the z-score in, and then I clicked on the part at the top of the, so it only highlighted the top part of the applet, and then took the area that was up there.
That's what I did. Everything to the right
Yeah.
of the score.
2.238. Then you just highlighted the everything to the right.
Yeah.
Good. Okay, I got you.
Okay. Question 10. Use the following information to answer the next 5 questions. Open up my spreadsheet. Mean GPA of BYU students is 3.5. Standard deviation is 0.7. It's well known that the distribution is left skewed. Great. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which is the sample of the means, which represents the sample mean of the 81 students who are selected? I would say that's approximately normal.
That's what I got.
Sorry, you broke up again.
I would say it's a normal distribution, even though it's left skewed because it's a large sample.
Oh, what?
So normal.
Normal, approximately normal.
Yeah. Okay.
Okay. Can you guys hear me?
Yeah.
Yes.
No. Can you guys hear me?
Yes.
Okay, cool. Question 11, what is the mean of the distribution of sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? Round to the first decimal. Would it still just be 3.5?
That's what I got.
3.5.
Because the mean of the sample means is the same as the mean of the population.
Right.
Okay. Okay. So then, what is the standard deviation of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population? So, do you use the same standard deviation as well?
No.
Okay, I was really confused on the parent population stuff.
So that would be the standard deviation of 0.7 divided by the square root of your sample size.
So 0.7 divided by the square root of 81.
Right, which would be 9.
Okay.
So
0.7 divided by 9. So it'd be 0.0. Okay, how far are we doing it out? To 3 decimal places. So 0.078.
yes, that's what I get.
Okay.
Does that make sense?
Yeah.
And that's basically what we use in the bottom portion of when we figure out the z-scores for the sample means.
Okay.
You got 0.07.
0.078. Yeah.
All right, 13.
Well, I'm sorry, guys. You broke up one more time. You said you got 0.07.
0.078.
Doggone it.
You get it, or you need me to text it?
Maybe just write on the board here to the right.
I don't have that on my tablet,
I did it. I typed it.
and I texted it.
Okay, that's what I got too.
Okay.
Perfect.
All right, 13. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students be less than 3.3? Round your answer to 3 decimal places. So 3.3, 81. So my z-score is negative. Z-score is negative 2.571. Yes. And they want to know what's the probability it will be less than that. So I got 0.0051. So it'd be 0.005.
0.005. Okay.
Sounds good.
Is that what you guys got?
Yeah.
Okay, 14. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? Less than 3.3. So then we would just put the I know you guys already have it because you put that in the template and you just put it to the right side.
Or you could just do one.
No, I had a question before I answer. There's 2 ways to. I remember when we went over this lesson, they gave us this new way of basically getting the z-score. that has the square root in the formula?
Mm-hmm.
Does that make sense?
Yes.
You're gone again.
But we already got the z-score for 3.3 in column 13.
Right. I'm just wondering, when we use that formula with the square root on it, how do we know when to use that formula rather than just the mean minus x divided by standard deviation?
That's for all of your data. When we take a sample of that data, that's when we use the sample size in there and we use the square root.
Okay, that makes sense. So this one,
Like for instance, all students at BYU Idaho, if we took, and let's say there's 10,000, I don't know, but let's say there's 10,000.
mm-hmm.
The mean is 3.5. So if we wanted to figure out the probability or the percentile of a score of 3.3, then we would just do that, because that's just a simple one, a single one based on the entire population of 10,000. But here we're just taking 81 randomly selected students. So that's a sample means is going to equal the same as the mean for all students, and that's your population mean. So when you're saying we have a sample of 81 students and the mean of that sample is 3.3, the standard deviation for that would be your 0.7 divided by the square root of, which in this case is 81. So that's, you use that to get your z-score.
Okay.
Does that make sense?
So on these questions, what is the so the sample size is 81. What is the overall size?
We don't know and we don't care.
We don't care. Okay.
It's
So
all, your size is all BYU Idaho students.
okay. So then the standard, I mean the z-score, was it negative 2.571 for that last one?
Yes.
Mhm.
Okay. Now I see. I was just trying to figure out where I plug in the numbers, and now it makes a lot more sense.
Okay. And on this one, since we know that below that is 0.005, then above that would be 1 minus
Would
0.005.
be 0.9949.
Yep.
What is it? I'm sorry.
0.9949, but I don't know. 0.995.
Okay. Cool. All right. And this last one, I may need help because I know I needed to find the p-value, but I may have done this completely wrong. So the United States Coast Guard assumes that mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. And I got 0.055, but I don't know if that's right or wrong.
Okay, so what'd you get for your Z-score?
The Z-score, okay, now I have to find where I wrote all this one down. I got for the Z-score 1.920, negative 1.920.
That's what I get. So the question is, as extreme or more extreme?
So that's finding the p-value, right?
Right, and I would say in this case would be below that because we're already off to the left.
Mm-hmm.
That would be extreme. So I get 0.027.
So how did you find that, Pete?
Just took the area to the left of that.
So do you go to the normal probability applet
Yes.
and you type in the Z-score of negative 1.920
Mm-hmm.
and you go to the left?
Yeah, because that seems to be extreme.
Okay.
We want more extreme, so that would be to the left.
Okay. I see. I got it now.
If it were a positive value above 185, I'd say the extreme would be looking more towards the right.
0.0274. Okay. I see. I got it.
Let me see if I'm correct. P-value is the same as probability, right?
Okay.
Probability and area are the same.
Okay.
Am I on the right track there?
Yeah.
Okay.
All right.
What you got?
0.027.
Yeah.
Okay.
Okay. So go to submit quiz. Yep. We got that one wrong.
That's the only one we got wrong.
So I don't know.
Huh. Well, that's not good.
All right, track it.
So 5 is a mean. So standard deviation.
You guys want to try to do it again, yeah?
Yeah, I don't. Yeah, I'm not sure how to do that one.
All right. I'm wondering if we should go both the far right and the far left. Because that would be as extreme both ways, or more extreme both ways.
Mm-hmm.
So, and that answer I would get is twice that basically, or 0.0549, so 0.055 for number 15. So let me write these answers down. 1 and 2 are true. So 3 was 0.175.
Well, in the lesson, it says that the p-value is calculated by finding the area under the normal distribution curve that is more extreme, further away from the mean than the z-score. So it seems like we did it right, but
Yeah. So,
Yeah, that's what I thought.
do we want both the extremes, the lower and the higher extreme?
Okay, note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. So yeah, it would be both.
oh, so it's both of them added together. So it'd be that 0.55.
So do we need to put the 0.027 comma then the other one?
No. It
No.
would just be that one added together, so it's 0.055.
Okay. Okay, so let me pull up my quiz again and I'll start doing this again.
Middle. 5 is all large numbers. 6 is 1.05. 0.8.
So what were you thinking it was, Pete? How did you think we do it?
They want what's more extreme in either the positive or negative direction. So it's kind of like an absolute value. So I highlighted below the z-score and above the positive z-score. And that gives me 0.0549. They want it to 3 decimal places, so that's 0.055.
0.055.
And if that sounds wrong, let me know.
I'll check this out. Okay. Heck. Oh, crap. That is correct.
Yeah,
Yeah.
the 0.055.
Yes. However, I typed in answers wrong. So hopefully they take your higher score, right?
Oh God. I hope so too.
Crap.
I'm double checking mine right now.
That's what I did last week. Was when we went back, I hit the wrong one mistake, and I still got one wrong.
Did they take your higher score?
I think
Well,
Okay, because I typed in 3 of them wrong,
so.
and
Oh gosh.
so I got worse on this one than this one.
if you email the instructor, I think maybe you can adjust your score.
I hope so. But 0.055 is correct.
Okay.
Oh my goodness.
So, yeah, I'm hoping to do this right. So, I hope I wrote all these down right.
Okay, that's weird. What did you guys have for? That's really weird.
For
Number
what?
number 12. What did you guys have? What's the step?
0.078.
Number 12?
Yeah. What'd you get?
Oh, I see what I did wrong. I put that down on number 13. I did it. So
Oh,
I got one off when I was going down.
again.
Dang it.
Yeah, I bet if you emailed the instructor though, he probably gave you the points because all of these add up to 100%. That's what I got. So.
Okay. Well, good.
Yeah.
Crap.
So that was 0.078 on 12.
Yeah. 12 is 0.078.
Yeah.
13 is 0.005, 14 0.995, and 15 was 0.05.
13 was?
Oh, hopefully I wrote all these down right. Scott. Submit. Yeah, I've got them all.
Awesome.
All right, I got to get going, guys.
All right. Thanks. So Friday.
Yep, Friday sounds good.
Yeah.
Pete, you want to initiate the call next time?
Yeah, I can do that.
Okay, that'd be great. Thank you guys. See you on Friday.
Okay. Thanks, guys.
All right, have a good one.
Good week.
Bye-bye.
Okay,
Bye.
bye.